This is Muskan Fatima from CSE branch B section. Today we are going to discuss about linear algebra and calculus tech talk. The topic is fill in comparison between Gauss-Jordan elimination and Gaussian elimination. Then let's get started. Today's session is about Gauss-Jordan and Gaussian elimination methods. So let's get started with the introduction. Gauss-Jordan elimination and Gaussian elimination commonly are known as the elimination methods. They are used to find inversion of the matrices. Let's learn to use these methods to solve linear equations with several unknown variables. We will also introduce the row echelon form of a matrix and discuss the difference between Gaussian elimination and Gauss-Jordan elimination along with the similarities. We use both these methods to find the inverse of a given matrix in a very simplified and easy way. So let's start. Comparison between Gauss-Jordan and Gaussian elimination method. In Gauss-Jordan method, the given coefficient matrix is transformed into diagonal matrix. Whereas in Gaussian elimination method, the given coefficient matrix is transformed into upper triangular matrix. Both are done in direct method, and in Gauss-Jordan method, there is no need of back substitution method. Whereas in Gaussian elimination method, we obtain the solution by back substitution method. Gaussian elimination method. So let's get to know about Gaussian elimination method. Gaussian elimination is a method for solving systems of linear equations with several unknown variables. It works by bringing the matrix representing the equations into row echelon form and resolving the unknown variables by back substitution. The coefficient matrix is transformed into an upper triangular matrix with the use of operations, that is, row operations. No column operations should be applied. Gauss-Jordan elimination method and Gaussian elimination method are almost same, but the only difference they have is that the Gauss-Jordan method transforms its coefficient matrix into a diagonal matrix, whereas the Gaussian elimination method transforms the coefficient matrix into an upper triangular matrix. Next, we have two equations. X plus 3y is equal to 10 is our equation 1, whereas x minus 2y is equal to minus 5 is our second equation. Now 5y is equal to 15 when we do equation 1 minus equation 2. You can eliminate x by subtracting equation 2 minus equation 1. Now by this we get y is equal to 3. Now you can simply divide by 5 to obtain y. X plus 3 into 3 is equal to 10. Plugging y into equation 1 gives you x. We get y as 3 and x as 1 now. Y is equal to 3, x is equal to 1. You can represent this system of equations as a matrix vector multiplication, where x and y become your vector b and the coefficients are represented in a matrix A. AB is equal to C. So matrix 1, 3, 1 minus 2, xy is equal to 10 minus 5. Now let's know about row echelon form. The row echelon form is a diagonal matrix where all entries below a leading coefficient are 0. Some textbooks also state that the leading coefficient must be equal to 1. The following matrix is in row echelon form with the leading coefficients in each row along the main diagonal and everything below them equal to 0. So here we see the matrix 1 A12 A13 0 3 A23 0 0 2. Here we see the A11 part is 1, A21 is 0, A31 is 0. The order of zeros is increasing down the rows. The goal of Gaussian elimination is to bring the given set of equations into the following matrix format, that is, into upper triangular matrix format. The leading coefficients given on the main diagonal are illustrative and will be different in every example. The given matrix is referred to the general form of the matrices. Next, example of Gaussian elimination using echelon form. To solve our linear system of equations in matrix format, we can apply the Gaussian elimination method according to the same principles. Let's use an example with a 3 by 3 matrix A and a vector B. Here, AB is equal to C. The given matrix is 1 3 1, 1 minus 2 minus 1, 2 1 1. The vector matrix is XYZ, and the equivalent matrix is 10 minus 6 10. Now perform row operations. Row 2 minus row 1 and row 3 minus 2 into row 1. We finally get 1 3 1 0 minus 1 minus 5 minus 2 0 minus 5 0. Whereas 10 minus 16 10. Here we can see that the rows except the first row have 0 as the first coefficient. Now performing row 2 plus row 3 and swap row 2 with row 3, we get an upper triangular matrix. Now perform row 3 by minus 2 and row 2 by minus 5. We get a perfect upper triangular matrix. That is what we do in Gaussian elimination method. Now in our matrix A, we have attained a so-called row echelon form. From the row echelon form, it is easy to figure out that Z is equal to 3 and Y is equal to 2. By back substituting Z and Y into the first equation obtained by multiplying the first row of the matrix with our vector, we get X. 1x plus 3y is equal to 1z is equal to 10. It gives 1x plus 6 plus 3 is equal to 10. Hence, x is equal to 1. Augmented matrix. As we have realized during Gaussian elimination, the vector b was not relevant. Therefore, we can represent our linear system of equations in an augmented matrix consisting only of the coefficients. Our previous example would look like this. The elimination process is easier since you don't have to care about x, y, and z. You only need to turn this augmented matrix into row echelon form and then you can bring your variables back in. Now let's get started with Gauss-Jordan elimination, that is Gauss-Jordan method. Gauss-Jordan elimination, more commonly known as the elimination method, is a process to solve systems of linear equations with several unknown variables. It works by bringing the equations that contain the unknown variables into reduced row echelon form, that is into identity matrix. It is an extension of Gaussian elimination which brings the equations into row echelon form. Now, what is reduced row echelon form? Let's get to know about it. A matrix is reduced into row echelon form exhibits the following properties. The matrix is in row echelon form. The leading coefficient in every non-zero row equals 1. Every column that contains a leading one has 0 entries everywhere else. That is, it can be considered as an identity matrix. The goal of Gauss-Jordan elimination is to bring a system of equations into the following format, that is given below: 1 0 0 0 1 0 0 0 1, and the vector matrix will be XYZ. The equivalent matrix will be B1, B2, B3. This procedure is similar to Gaussian elimination. Now, by this picture, we understand that Gauss-Jordan elimination is having a diagonal matrix and can be also be represented as an identity matrix, whereas Gaussian elimination is an RAF matrix where we have 1 1 1 in our diagonal matrix, but it is like an upper triangular matrix. So here we can understand that Gauss-Jordan elimination, Gaussian elimination are almost same, except the fact that Gauss-Jordan elimination is completely related to the reduced row echelon form, whereas Gaussian elimination is related to row echelon form, direct row echelon form. These both are direct methods and their coefficients change into diagonal matrices. Here we use both of these methods to find inverse of matrix. after doing this, we get the inverse matrix automatically. We take the matrix, we equal it to AI. If we take a matrix A is equal to AI. I and A will be compared, and as per the row echelon form, as per the reduced row echelon form, we get a diagonal matrix in the left hand side, whereas we get a different matrix in the right hand side. This I is considered as B, and the A from right hand side goes to the left hand side. A I A B is A inverse B is equal to I. So hence the matrix we obtained is the inverse of the given matrix. Hence, here we can see Gauss-Jordan elimination, Gaussian elimination are the methods that are used to find inverse of the matrix of the given one. And at last, we end the session. Thank you for listening to my session. Thank you.